Hello chemistry fans, and welcome back to Chemistry 1032 problem solving session here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I'll be guiding you through this problem today. Drawn below is a molecule of A lactose. It should be alpha lactose. Let me just correct that real quick. Alpha lactose. Circle the anomeric carbon, or carbons, there might be more than one. Square the glycosidic bond, which means draw a square around it, and then describe it. That's interesting. All right. Well, first things first, let's answer these questions in order. Circle the anomeric carbons. Recall from the last video, or a previous video, that the anomeric carbons were the ones that were directly to the right of the oxygen in the ring. So this is the anomeric carbon, and that is an anomeric carbon. Okay? This is alpha lactose, so notice the OH here is in the alpha position. Square the glycosidic bond. Now, a glycosidic bond is an ether bond that connects to, let's just say sugars. Okay, so here's a sugar, and this is the bond that connects them. So let's put our square, let's get a blue, I guess. I guess it'll be more like a rectangle. There you go. It's more like a rectangle than a square, but you get the idea. Now, that is our anomeric carbons, and this is our glycosidic bond. Now, we have to describe the glycosidic bond. And what I mean by that is I want you to tell me what type of glycosidic bond is it? Is it alpha or beta? And what carbons it's between. So to do that, we have to understand the numbering system of the Haworth structure. Now recall when we were naming organic molecules, we had to give the carbons numbers. And I told you how to do that. Now in a Haworth structure, the numbering system is always the same. This is always carbon number 1. This is 2. That is always 3. That one is 4, 5, and this carbon is always 6. Okay, always. It's always like that. So on this one, this is 1, 2, 3, 4, 5, and 6. Always. Okay, every 6-member ring, Haworth structure, carbon 1, 2, 3, 4, 5, and 6. Never fails. Always works that way. Okay, so this is a glycosidic bond between carbon 1 and carbon 4. Okay, so carbon 1 of this sugar, carbon 4 of that sugar are making the glycosidic bond. Now, the other question we need to answer is the glycosidic bond pointing up or pointing down? Because they can do either, right? Remember we had alpha and beta Haworth structures, right? The glycosidic bond can be alpha or beta. And we said that if the oxygen, so find the anomeric carbon, the oxygen here is pointing up. We don't care about the oxygen over here. We don't care about this one because we're describing the glycosidic bond. The glycosidic bond, the carbon to the right of the oxygen in the ring, is going up. So this is beta. This is beta. So the glycosidic bond is beta dash 1, 4, carbon 1, carbon 4, and then just write glycosidic bond. Okay, so now again, it's beta because it's facing up. This is the anomeric carbon we're worried about. This one over here we don't worry about because it's not part of the glycosidic bond. Come over here. Carbon, oxygen is pointing up, so that's beta. The bond is between carbon 1 and carbon 4 of the two sugars. So it's a beta 1,4 glycosidic bond. Now, I understand that a lot of you will be confused by this. That's okay. Work some other problems in your book. Call a tutor. Get a hold of your professor. Don't let this slide. It's actually very simple to do if you practice it a little bit. All right? Now, I expect all of my students in my class to be able to do this. To be able to name the glycosidic bond, describe it, number the Haworth structures, circle the anomeric carbons, put a square around the glycosidic bond. I expect all of you to be able to do that. It's really not that hard. All right? Now with that, I'd like to wish you good luck and good chemistry.